Okay, the next item on our agenda is to talk about decision analysis, and that includes discussion of dynamic programming, which is another approach to trying to find an optimal solution, not necessarily the optimal, right? So anyway, we're going to take a look at these two things. This first video will be just kind of an overview of decision analysis. And I'm going to ask you to do this for your project as well. So, hopefully this will be valuable to you. So we're not going to talk about APs and Garage. We'll do that next week. But I want to talk about how we can represent problems using or borrowing techniques from computer science. And artificial intelligence is one really great example of how computer scientists have represented problems using this technique. And then we'll do a decision analysis of something that's familiar to you in making decisions and using this tree approach to finding or representing problems and finding good solutions. And then we'll do a dynamic programming example. I'll describe what it is. I've got a couple of examples that kind of I just want you to be exposed to the approach. This is something you can stick away in your toolbox, and if you ever have need for it, here it will be. We're going to talk about kind of a special case of this later on. So, decision analysis, as I said, uses trees, really graphics, to represent choices. So the nodes are decision points, or they can also be, okay, if I do this, then something will happen, right? And that's also a choice, really, but nature is making that choice. And this really is a great tool for kind of evaluating alternatives and representing the big picture, so that we can see all of the variables at once. It's great for identifying choices that are available to us. And sometimes, we might choose to make second best choices just because of the probabilities involved in, what happens if some extreme event occurs. And it's a great way to present a project to a client or a decision maker. So this really lays it out. This is valuable for us, right? We like to kind of lay things out and understand things. So this really does that, and it avoids oversimplification. And it's very structured, a really great representation of what are otherwise very very complicated situations. So it's really a good way of expressing or defining this wide range of choices, and we can include risks. So what's the probability of this something happening, kind of a thing, right? So we're going to go through a couple of examples, and we can include decisions. What are some management decisions or investment decisions? What are the factors involved? What are the uncertainties, as you've been working on? So the decision tree shows the range, all the choices available, can be over periods of time, and because it shows everything, it allows you to identify plans that might exploit opportunities. So I'm going to hopefully get to the example here without all these stupid bullets. Wait a minute now. So it has two graphical elements: decision points and chance points. So a typical decision tree would look something like this. So I make a decision to do something, or something else, right? I have two choices in this simple example. And then once I've made a choice, something could happen, right? There's a chance that one thing will happen or something else will happen. And then I need to make another decision, and so on and so on. So I can represent my decisions that I make and represent things that can happen with their associated probabilities. And based upon that, if that happens, if I make this choice and this happens, then I'm free to make another decision. Right? And, then there might be chances available and so forth. So there's a probability associated with each chance decision point, and then a value associated with each decision. So here are the probabilities, and then the values of making certain decisions are at these endpoints. So the idea. So let me give you a really simple example that's close to my heart. Something that I really hate is getting caught in the rain without a raincoat. So let's say I can use this. I can calculate it, the expected value of outcomes given a sequence of decisions and chance happenings. For each set of alternatives, I can calculate an expected value, and I can choose the alternative that's best, the best value for me. So in this case, let's say I have a decision to make. I'm walking out my door in the morning. And do I want to bring a raincoat with me or not? Okay. So the chances are, if I choose a raincoat, the chances are it will rain today with some probability, or it will not rain with some probability. Right? And in either case, there's that same chance happening, right? So, if I have my raincoat and it rains, I'm happy with that. So that's a positive value. I made these numbers up, but hopefully you'll get the idea. So this has some positive value associated with it. And if I brought a raincoat and it didn't rain, well, there is a cost associated with that. I have to drag the stupid thing around with me wherever I go. So it's a kind of a negative value. And down here, if I don't bring a raincoat, but it does rain, well, that's a significant cost. I do not like getting caught in the rain without being prepared, especially when all dressed and stuff. But if I don't bring a raincoat and it doesn't rain, well, okay, so there's some value to that because I'm not dragging the thing around and it didn't rain, so I'm happy. So what's the expected value of each of these choices? That's the question. Well, the expected value of choosing a raincoat is the probability of it raining times the value associated with that choice, plus the probability of it not raining with the value of that path or choice. So it's 0.8. My value is 0.8 for choosing a raincoat. Now the expected value of not choosing a raincoat, right, is the probability that it will rain times the value of that particular choice, plus the probability of no rain times the value of that choice. And I end up with an expected value of not choosing a raincoat, choosing to bring my raincoat. So I'll probably bring the raincoat if there's a 40% chance of rain today. That's the outcome. Given these value terms that I've assigned, which are, I don't know, somewhat random, but they have some validity. Okay, so the idea is you start at the rightmost edge of a tree, and you evaluate expected value for those alternatives on the right-hand side and then identify the best one. That's the value of the decision point, and then repeat this process, proceeding leftward until the end is reached. So let me give you an example. By the way, this gives you possibly more than one path. Right? It's not a simple plan. It's dynamic. It allows you to see all of the different choices and all the different values and so forth in a sequence of choices. So let's do a simple example, and I have a really complex decision tree that I pulled from someplace. Actually, let me stop here. It's been 10 minutes, and I'll start with another video to do the two examples that I've had left.